Uh, in this video, we are going to see how we can analyze a truss using standardsolver. So this is the truss we want to analyze, and this is the expected results for our analysis. So these are the support reactions, and these are the member forces. So let's see how we can analyze this truss problem using standardsolver truss analysis module. So we are in the module. Let's delete what we have there. Okay, let's keep the first element. So let's delete everything. First element N1. This will be here. Let's create the second node. So I'll be creating nodes this way. Then I will create truss. So let's go into which is 8 and 3 is 8, 8 and 4 is 16 and 8. Then N5 is only 6 down, so just 2 from the base, and high X is 16. Now create the nodes at these points. So this is 4, height wise this is midpoint here, so it's 4. Then this point is at the midpoint of this 6 meters, so it is 3 from here, so it is 5 from the base. So 5 length right 16. So we got all the points. Let's create all the elements. N1, N1, 2, and 2, and 2, 3, and 3, and 4, and 4, 2, and 5. There is a N7, we need to change it. N7 is actually not 16, it is at 12. Yeah, let's go back. Then N1 to N6, then N6 to N2, then N6 to N3, then N3 to N7, N7 to N5, my computer seems going a little bit slow. Yeah, okay. Then N7 to N. So we have all the elements now. Let's create the restraints. So N1 is pinned, true, true. Then N5 is also pinned, true, true, true. Yeah. Now, now these are a truss joint where the elements are free to rotate about this joint. So what we can do is we need to release the elements at both ends. So with the first element, everything to true. It is a bit tedious process. So now we can see the elements are, we put hinge joints. So the elements are free to rotate about the node. But you can see from here, if you release all the elements with respect to a node, that is not the realistic scenario. Like imagine like these elements are rotating about this element shouldn't have a hinge here. So to actually model a truss joint, there is two approaches which is outlined here. So we need this rotation of this node to go somewhere. So we need to fix the rotation. So it is a hack. So we just make the rotation fixed. So you only need to do this for the truss joint if you have released all the elements coming to that node. So the rotation has to go somewhere for the analysis. So you need to fix it, fix the rotation of that node, but the elements are free to rotate about that node. And the node will translate with all the elements. So just remember if you release all the elements coming to a node, you need to fix the rotation of that node. So rotation can go somewhere. Similarly, if you do, or if you don't want to put this restraint here, rotational restraint, you just don't fix one, like you don't put hinge on one of the element, then it will also do like this. You don't put, yeah, for example this one, you keep one element without hinge, so the rest of the elements can rotate about that element. Yeah. If you are not clear, just send me an email in this email ID. I will help you with that. So we have, let's apply the loads. So the loads are at node 2, we have a 15 kilonewton, then minus 10 kilonewton downwards. Then here we have this node 3, we have a minus 20 kilonewton, and node 4 we have a minus 10 kilonewton as well. So we have the loads and we have the structure modeled, and we just use default sections. We are not bothered about the deflection values. So let's run the analysis and see. So now we have the results. So we look at the reactions 5, 15, minus 20 and 25. So these are matching. Then the element forces, we zoom in here, minus 25. So this is the value, this is the slope. So this 25. Then you can see this element is 10. Minus 15 for this element. 7.1 along the 7.1. So you can see the results. there is not much deflection, so deflection values are 0. So yeah, this is how you analyze a truss using standard solver. This is still an alpha version, so be a little bit careful. Just make sure the results make sense before you use it. So yeah, thanks for watching. It is very easy to use. Maybe not very easy if it is a large truss element, but you can analyze a small truss very quickly. So hope you enjoy it. Give it a try. Thank you.